Previously, we talked about RAG and AI agents, but today, let's level up. We are building an agentic RAG system. You might wonder, why do we need an agentic RAG system? Isn't RAG enough? Here's the thing. What if your data is split across multiple databases, or the info you need isn't in your database at all, and the LLM need to search the internet? Or maybe the LLM already knows the answer from its training data and doesn't even need to look anywhere. The standard RAG system can't handle this level of complexity, but agentic RAG system can. We give the LLM the ability to decide where to look for the information. It becomes a true agent, choosing between querying specific database or search the web, or simply responding using its own knowledge. To make this happen, we will use function calling and a little bit of prompt engineering. We will design a system prompt that explains what type of data is stored where, which tool or method to use for retrieving it, and a clear instruction on how to combine the results for the best answer. So why is this cool? This system is dynamic, efficient, and super scalable. Imagine a personalized assistant that knows exactly where to fetch info you need, whether it's in database, online, or already in its brain. Let's open VS Code. First, we will create a requirements.txt file and add all the necessary packages. Before installing them, let's create a virtual environment and activate it. Now install the requirements. Let it install in the background. First, we will get the data into the database. So we will create an upload.py to manage the database. So let's import the necessary packages. Create an embedding function that uses OpenAI's text embedding 3 small as the embedding model. As we are using OpenAI, we need the OpenAI API key. You can get it from platform.openai.com and store it in .env file. For this project, we will use some blogs I found on the internet. Let's fetch the content of these 3 blogs and store it. Next, we will convert them into chunks and store them. Now, let's initialize our database. We will be using ChromaDB for this project. ChromaDB is a popular open source vector database, and we will be storing our data and embeddings locally. We are creating persistent client, so we don't need to convert the data into embeddings every time. Next, we will create a function that will create a separate collection for each blog, and then we will upload the data along with the embeddings to the database. Let's create a for loop to upload the data. Now, run it. Okay, now it's in the database. Let's check if the data has been correctly uploaded. We will create a function that will perform vector search. We will also be using this function as a tool for our agent. This function takes the name of the collection and the input string to use for vector search, and we will retrieve the top 5 chunks from the database. Before we check if this works, let's comment the part that is used to upload the data. We don't want to upload the data again. Okay, let's run it. Looks like it worked, and we got the relevant chunks to our query for what are AI agents. And one of our tools is ready now. Let's create internet search tool. We will be using DuckDuckGo. It's free to use and does not require any API keys and easy to set up. So we'll create a function for this. Let's find out who won between Jake Paul and Mike Tyson. Actually, I missed the match. Now we run it. Looks like Jake won. I was betting on Mike. With this, our tools are ready now. Now let's create a tools.py to declare tools. Because we are using OpenAI function calling, our tools definition should be structured within an array. Remember, it's important to provide description of the tools here, as it will improve the performance of the model. Finally, we'll create a main.py where we will set up our agent. Let's import the necessary libraries and our tools. Set up OpenAI client, and for agent we will create a function. Normally when we use function calling, we use the model twice. First, we will check which tool to use, or does it even need to use a tool. And second time, it will combine the output from the tool with the user input and send the final response to the user. This might look complex, but it's very simple. When we use function calling, the output from the first response is structured if it needs to run any tool. So we are just creating a small script that will extract the output from the response, like which function to run and parameters to use for that function, and then run it. After running it, pass it for the second response. If it didn't use any tool, then just print the first response. Now let's create a main function where we will write a system prompt. As you can see in the prompt, we are letting our agent know which collection to use while performing vector search, or it should perform any internet search, or maybe answer it from its own knowledge. Let's run it. First, we will ask, who are you? It should answer this from its own knowledge. As you can see, it didn't call any function. Next, let's ask, what are AI agents? Now, if you remember, there is a collection for that in our database. So it should perform vector search. And it's working. You can see it has also mentioned the source. Now, let's see if the entire search is working. So we'll ask it something it has not been trained on and is not in our database. Let's ask it who won Mike Tyson versus Jake Paul. And it's working. And we have successfully implemented Agentic RAG system. Till now we have been using single agent system, but it can be improved further by using multi-agent system with frameworks like AutoGen and TrueAI. The GitHub link for the project is available in the description. And see you later.